Okay, so good morning, students. So let me warmly welcome you to today's workshop. So today we'll actually talk about artificial intelligence. And so we already had three workshops before this, and we have a couple of more that we will do in January as well. So if you actually, for some reason, missed those sessions, you can access them. So if you go to the CodeFest website, let me actually try to go and then show you where they are. So from here, you can actually access the school workshop resources or workshops under this. So if you go under workshops, you see this, and under resources, you can actually see the previous sessions that were conducted, the links, the PowerPoint slides, recordings are also there. There is a YouTube channel. So in the YouTube channel, we actually have all the sessions that we had. So yesterday we had MIT App Inventor, then we had Scratch, then we had developing Python GUIs. If you are interested in, if you have not registered and you don't know about CodeFest school categories, there's a video here, School Competition CodeFest 2021. It's a very short video, 5 minutes, that will kind of tell you how to register and then compete in the competition. And there are some videos from the previous year as well. So if you want to register and you haven't done that, you can go under competition details. Actually, let's go under registration. So registration will actually have the registrations. So depending on your age group, you can either join senior, junior, or primary category. So if you actually go into one of these things, you can actually find out the requirement. Sorry, this is the form. So grade 10 and upwards is the senior category. And you can also find out about competition details if you come down. So if you want to know about the junior contest, all the details are there, the theme, the prize, the winning, and the finals will be there on the 10th of February. So students, please use the chat window to ask any questions that you have as we go along. So let me actually move on to today's session. So in case you don't know me, I'm Dr. Nuwan Kodagoda, and I teach at SLIIT, the Faculty of Computing. Now, today's session is a bit different from the previous sessions that we had in terms of this is an introductory session into something called artificial intelligence. So I believe you're here because maybe you have heard about artificial intelligence and machine learning, and you want to know more about it. In today's session, actually, what we will do is we are only going to do an introduction to AI. I will not show you how to really write programs or develop AI solutions. That we will cover in January. So using AI in your programs is how you actually use AI in your solutions. That is something that we will do in January. But for today, it's mostly an introduction about what AI is, to know about it, what are the issues related to AI. So those are like the things that we will discuss. So I'm hoping to cover these sections. I will define these terms: artificial intelligence, machine learning. I think you're familiar with programming. So at school, maybe you have done Scratch, or maybe it's Python, or maybe it's Pascal, or you might have used some other programming language. Now, machine learning is very different, or artificial intelligence is very different from that. So we'll try to find out the differences. What are the differences in this machine learning or artificial intelligence? And in fact, why do you have so many names? What is AI or ML? Are they the same or are they different? And you will also learn at the end of the session, what kind of problems we can use for normal programming, like writing code in Scratch, Python, Java, those kinds of languages, and what kind of problems this AI stands for artificial intelligence. And normally we say AI/ML. ML is machine learning. So we normally use this term together these days. So we'll try to see what kind of problems can be solved using AI/ML. And the current uses of AI/ML. Those are the things that I want to cover. Basically, this is the high-level picture of everything. So if you remember, or maybe you don't know this, but the very first computers came about, the electronic computers came about in the 1940s. So way back then, in the 1950s, a group of people thought of writing to make computers intelligent, intelligent as humans. So they started and they used this term artificial intelligence in the 1950s. And they actually thought that it would be very easy to teach a computer to be like a human. But in reality, it was much different. So in the early days, like in the 1950s and 60s, scientists actually wrote programs that can play checkers, like, graphs. And they wrote programs that can diagnose medical conditions. But what they found very difficult to do was things like what very small children can do. Like, for example, if you are given a image of a cat and a dog, to get a computer program to recognize a cat, get a program to recognize a dog, or to get a computer program to control a robot that can walk. So very basic things a 3-year-old child can do, what people and scientists found it very difficult to do in the very beginning. So, but what was surprising was, like, intelligent things like, playing chess, being a doctor, those kinds of things, people actually developed solutions in the 70s and 80s. So this thing called machine learning came about in the 1980s, but it was really very recently. Actually, from 2012 onwards, there was this thing called deep learning. So deep learning is a subset of machine learning. It's part of machine learning, and machine learning is part of artificial intelligence. So artificial intelligence is the big picture. Inside that, you have something called machine learning. So it means that in artificial intelligence, we talk about other things as well. But machine learning is a particular type of artificial intelligence that we have, and deep learning is a very specific type of machine learning. So today, everyone talks about artificial intelligence and machine learning. It's mainly due, people, if they talk about those are mainly talking about deep learning, which we will look at. So this is very recent, like it was something around 2012 that deep learning became very popular. So one of the reasons was, like, computing power. Computers became very powerful, and scientists were able to come up with very good algorithms that enable this thing called deep learning. So in today's session, since it's an introduction, as I said, like, please ask questions if you have any. But otherwise, I will actually try to show you some interesting videos so that you can learn certain things as we go along. So I'm going to show you an important video that happened somewhere around 2017. Let me play this.
For decades, human beings have played games against computers. At first, computers struggled, but then they started winning.
Watson, what is greed? Yes.
And now they've become so dominant that they're raising doubts about the future of humanity. The latest emblem for existential dread is Google's DeepMind project, which created Alphago, an AI program that's become unbeatable at the most complex strategy game on the planet. While the game of checkers has 10 to the power of 20 possible outcomes, and a game of chess has 10 to the power of 40 possible outcomes, Go has more than 10 to the power of 80 possible outcomes. Alphago is trained to analyze situations itself by breaking the game down into tiny parts and visualizing all possible moves. Last week, it played the world's best Go player, 19-year-old Ke. With the help of a human handler, Alphago beat him 3 times, and after doing what it was designed to do, retired from the game.
在这次比赛完之后，在他继续又不停地进步之后，我觉得他对我而言就是100%。
If a system like AlphaGo can learn all the moves in Go well enough to beat a person, then it has the potential to replace lawyers and accountants among dozens of other jobs. It might be perfect, but it has no way to navigate human politics.
Okay.
For decades.
Yeah. So that kind of like shows like that was a very pivotal moment, like where AlphaGo actually beat the world's best Go player. So Go is actually more complicated than chess. And what is interesting is like there was this version of AlphaGo which was called, which basically like was able to learn things by itself rather than a human teaching it. So let's actually let me kind of like ask you this question, like where have you seen AI and ML? Have you seen AI and ML? Maybe you can use the chat window. Have you seen AI, artificial intelligence, and machine learning in your day-to-day life? And if you have, can you give me some examples? So you can use the chat window to answer. So actually, like if you look at everything that you do, like I'm sure like because of the pandemic, you are using computers or phones or maybe tabs. So you use so many devices, and everything that you do, like for example, like if you actually watch YouTube, there is a recommender system. So the next video that you watch will be similar to what you have watched before. So that is artificial intelligence or machine learning. Or if you go online shopping, what you see will be based on what you have selected before. Most of the things that you do in your phone, like if you take a photo, you know that your photos are categorized according to what is there in that. And it will actually create movies and things like that related to various things that you have done. So that is where you find artificial intelligence and machine learning. So actually it's there everywhere in our lives, right? So let's actually run this video once again. Like I want to use some videos to show you some interesting things. This one will show you the current uses of machine learning and AI. Actually, it's everywhere. It's very difficult to think of a application now, whether you use a TV or whether you use a washing machine these days, like you will find AI and ML being used. So let's have a quick look at this short video about the current trends or currently how AI is being used in society.
Artificial intelligence is all around us, and we use it in different ways every day. You wake up, you go for a run, and your watch tracks where you're going, measures your heart rate variability using forms of AI. And probably AI was used by a farmer to grow the crops, the strawberries and the blueberries that I had for breakfast. Maybe you're in a car that has AI that helps sense the other vehicles on the road around it. You sit down at your computer, you start to use your email. It's all filtered by AI. Maybe you take a photograph, and the tools that help you sort your photographs, those are AI too. Artificial intelligence is everywhere, and it's becoming ever more present in our lives.
What is the temperature in San Jose, California?
AI and machine learning is the biggest revolution today. And it's on the order of the agricultural industrial revolution in the past.
I think technology is going to have a really hard time helping people like me.
There's a lot of hype, but there's a lot happening as well.
Organic pasta.
One of the great things about machine learning is how it's been democratized.
A sort of huge jump has happened with, and all of a sudden you're getting confronted with the fact that I might not be driving a car in the next 10 years.
Because it's software, the rate of change is so much faster. This technology will be created. We have no escape from it now.
People may think AI is going to take over the world. They're definitely nervous. Some of those dystopian things that we might think, oh, that could never happen, might actually happen.
To me, it's not what's going to happen to us, but what's possible to happen with us. And where can we go? I mean, it's sort of unlimited.
Okay.
Artificial intelligence.
So let me kind of, once again, like if you have any questions, please ask. So let me kind of like tell you the difference between normal programming and machine learning. Now say, if you take an example, this is how you normally write computer programs. Like if you have done Scratch, or maybe like if you have done Python or Pascal, Java or C, what we do is we write a computer program. And then we use data and then we get an output. I'll give you an example. Now at school, you might be having a term test, right? I mean, of course, physically you used to have term test before the coronavirus, but I think some of you might have had online exams. But after the term test is over, your teacher, your class teacher will give you marks, right? And then she or he will create a report card. And in that report card, she will say, okay, you have got an A for English, you have got a B for maths. So those kinds of things are in the report card. And also at the end of the report card, it will tell you what is your place. Like, are you the first in the class? Are you the 10th? Are you the 15th? So we can actually write a computer program to do that. So we can easily write a computer program to enter all the students' marks, and then we can teach it to, calculate the average, calculate the class average, calculate the rank, and then print this report card. So that is what you do in traditional programming. Now in machine learning, things are very different. In machine learning, what we do is actually we work with data. And you will see this in the next few slides. And we kind of say like what we want, and then it generates the rules. So machine learning is very different from normal kind of way that we give instructions to the computer. And that's what I want to emphasize. And these are two different things. So for example, if you want to create something like a report card and then rank students in a class, best way is to write a computer program, not use machine learning. But machine learning is useful for some situations where you can't use traditional programming, right? So there is a difference between the two. So let me kind of tell you about what is happening today in machine learning. So when people talk about artificial intelligence and machine learning, typically they talk about this, what we call deep learning models. So these are some technical terms, but these kind of like indicate the applications. So you might have seen like self-driving cars in that video. So I'm pretty sure like when you are adults and when you learn how to drive within 10 years or so, maybe even in Sri Lanka, like we will have self-driving cars. So in self-driving cars, basically they look at computer vision and image classification, right? So there are companies investing a lot of money to make this happen. The technology that is used is called convolutional neural networks. That's a particular type of deep learning model that is used. So these are like, you find today a lot of solutions where you can use image recognition, image classification being used today as part of AI. Now, all of you talk to your phone, like maybe you use Siri, or maybe like if you have an Android phone, maybe you talk to Google. So this, maybe you have an Alexa at home, right? And you talk to your Alexa to play music. So that is actually, your speech is converted to some text format, right? That the computer can understand. So this processing of speech, audio, you might actually do, natural language translation, like maybe like you type something in English and convert it into Sinhala or maybe French. So for those kinds of problems, we can use this type of network called recurrent neural network. I'm just only telling you the term so that you kind of get something out of this. Now, this Alphago that actually beat the world's best Go programmer, the new version of that is called Alphago 1. That actually uses reinforcement learning. In reinforcement learning, actually the computer plays by itself and learns. So normally we have to teach the computer about how to do something, but in some applications like in games and maybe in robotics, you can actually get the computer to try out things on its own and then figure out and even be better than humans, right? So this AlphaGo 1 is actually one example of that, where it actually is the best Go player now in the world, and it uses this thing called reinforcement learning. And this general adversary network is another kind of interesting thing where you can do creative things. So we used to think that only humans can do creative things like, compose music, then, draw, paint, create videos. But now it's possible for computers also to use this specific type of technology, which is also part of machine learning, to do those kinds of things, right? So once again, like if you have any questions, please ask. I'm going to actually put up a poll. I just want you to think about the problems that AI can solve. So by the way, you can't solve every problem using AI and ML. Some problems you can't solve, right? So let me actually launch this. So can you, you should be able to see this on your screen. It doesn't matter what you think, but can you think about these different, I have actually given 7 different things. So do you think, if you think that preparing grades in your school can be done using machine learning, you can select that. There are multiple answers, right? Can you make an attempt at this? Because like, it's really important that you think also. Otherwise, like you will not really get anything out of today's session. So it's anonymous, like it doesn't matter if you get the wrong answer, nothing is correct or wrong. Others will not see you. I will also not know who is actually giving a specific answer. Okay, since we are running out of time, okay, I can see some answers given. So that's very good. So preparing grades in your school. Actually, preparing grades in your school, it's best to use normal programming to do that. So AI/ML can be used, but probably that may not be a very good solution. Now, if you want to predict next week's vegetable prices, like these vegetable prices have been fluctuating, that's a very good example of machine learning. You can do predictions. So to do predictions, if you have historical data of prices, you can actually predict. So predicting the price of vegetables is a very good example of how AI/ML can be used. Then converting handwritten text to printed text. Once again, like it's very difficult to write a computer program to do that, but AI/ML can solve it. If you want to check grammar, of course, your teacher can check grammar, but if you want a computer to do that, these days people use machine learning. If you want to calculate someone's salary, well, you can actually define it by a set of rules. Now, to calculate someone's salary, you know the salary of that person. If he has done some extra work, you know that amount. So usually those kinds of things, we don't use AI/ML. So actually calculating a person's salary is best solved by writing a computer program. So you can solve problems by teaching the computer something. And in this particular case of calculating salary, or maybe like calculating your grades, the best one is to use normal computer programs. Also, like if you are in the rocket business and you want to launch a rocket to space, that is also like typically it's hard coded. Like, you can write a computer program to do that. You don't need to use AI ML for that, right? But if you want to create music and art, it's very difficult to write a computer program to do that. That is a problem that you have to use AI ML to solve, right? So what I want to say is like launching a rocket, calculating a person's salary, or maybe calculating the grades in your school. Those are like very good examples of programming problems. But other ones like prediction, checking grammar, creative things like music and art, those are like machine learning AI kind of problems that you can solve. Right? Okay, so thank you for sharing those answers. Now, I'll show you some demos of some very exciting things that you can do. You might have seen these kinds of things in movies, but these are really available now. And let's see if I can actually do a live demo of this. So I'm going to say allow. Yeah, so I'm not sure whether you can see me. I'll actually stop sharing, but you can't see the screen. But can you see my face? It's been mapped as I move along. It's actually a 3D model of my face, right? So even though I'm wearing glasses, it can have a mesh around me. So this is real time, right? As I'm talking, this happens. So these days, like even when you create movies, they use technologies like this, and you don't need anything. You just use a web camera. Of course, in movies, they use more powerful sensor capturing devices. And you can see the 3D model of my face. So this can be, maybe made into Spider-Man or some kind of character, and then it can be reanimated, right? So like this is actually capturing the face. There are ones that can capture the fingers. There are ones that can capture the entire body, right? So this technology is right there now, available right now. And these are examples of actual deep learning being used in real world scenarios, right? So hand pose is also something similar. So this is something that you can actually try out. And let me ask you a question now. These are pictures of 3 people. There's a gentleman, small baby, and a lady. So can you tell me which one of these 3 images is a computer generated one? Maybe you can use the chat window. Can you make a guess? Maybe if you look closely, you might be able to guess. Which one is the computer generated one? Or are these all real ones? So is A the fake one, or? Okay, so A looks a little bit fake, right? But actually that was a trick question. All of these are not real images. These people have not existed before. These are all computer generated ones. So you can see how realistic these images are. In fact, like there's a very famous site. So let me actually go to that. It's called This Person Does Not Exist, right? So there's a site like that. And if you actually go to that site, it will generate images. So there has never been a person like this ever. And each time, so it's actually generated by a computer program, right? It's not created right now, but then it uses this technology called general adversary networks to generate this, right? So yeah, so this is actually one example of how you can do creative things. So you might have seen this last one here. So generative adversary networks is basically the technology that you use to create creative things like photos, videos, music. So you have computer programs which are basically machine learning or artificial intelligence programs that can generate images like this, right? So here are some examples of what is out there. I'll show you a few and you can try out these things later. So here's one that will actually do colorization. You can actually go to this site and then upload an image, and I'll show you what is there. So this is actually an image of a train, and you can see this is colored, right? So, so these are actually black and white images which are turned into color. So the computer figures out that this should be green, and these colors are the people. Like we haven't written a computer program, but what we have done is like we have shown a lot of images of real black and white and colored images, and then it has figured out by itself how to do this colorization. Right? So this is one very famous example of colorization. Then, of course, you have seen these generated photos, but you can customize those images that are created. So these are all created images, and you can actually create a specific one. So for example, let me select, say, this guy over here, right? I think I can, yeah. So I can actually do various things like, I could actually change the ethnicity. You can say he's now, okay, Asian. Hair length, let me say it's long, and then apply. So I will get, so this is a guy, but long-haired guy, right? I can change the hair color. So let's say I want to make it brown, then apply. So these are all new images. These are not real people. You can actually generate this. So this particular website called Generated Photos use these adversarial networks to generate realistic images. And people actually use them for modeling because the prices are there, right? Then you have this lot of interesting things like, Artbreed. Artbreed is an example of where you collaborate with AI, humans collaborating with AI to create artistic things. So in here, you can actually create new artifacts, new art with the help of AI, right? So yeah, so it's taking a little bit of time to load. You can see it here. Now, what is special here is like some of these things are generated and you can customize. So for example, there is this particular girl here. You can actually change the age. You can change the gender. You can make her look more girlish. You can change the color, right? And then you can actually blend the images. Like you can take multiple images and create new ones. You can see this one here is actually combining multiple images together. So if you want to create some very, weird kind of images, it's possible to do that using AI. So you actually decide how to mix these images together, and you can use these tools to generate these images. So some of these things are mixed ones. So this is not really drawn, right? So you partially it's drawn and then you kind of change it to make it interesting. So artists kind of like can use these kinds of technologies, right? And let me show you one more thing. So this is actually something called deep art, which actually generates images like this, right? It can generate images like this. So I'm just trying to show you what is out there. So there's something called MuseNet. So this MuseNet is also very interesting because you can actually do things that what people thought was not possible before. Compose music, right? So now you have computers are able to generate like music similar to Mozart or to the Beatles. And so this is one particular site that you can go to and experiment. There are so many others available. So let me play one from Chopin, a piece, which is actually not a real Chopin piece, but it's actually a generated one. So music generation is also something that AI has taken into, and then artists and creative people now use these technologies together to do take creativity to the next level, right? So similar, like I think text to speech and then speech to text. So there are technologies like that. So here are some actual examples of artificial intelligence solutions which are there today out there. So there are recommendation systems. The recommendation systems, very good example is like if you go to YouTube, it will tell you what video to watch next. Then computer vision, image-based ones. Natural language processing, like, you can get a computer to actually even write essays or write poems. That is also possible, right? Then language translation. You have seen like, you use Google to translate Sinhala to English, English to Sinhala. So all these things are part of this technology called deep learning or machine learning. Then maybe like you want to group things together, like maybe like you have a lot of photos and you want to find photos which are having clouds, or you want to group ones where you are there. So clustering is something like that. Forecasting, like predicting what would be the vegetable prices next week, right? Then general adversary networks are the ones that we looked at. The creative stuff is done here, and reinforcement learning is where a computer actually learns by itself, right? So it is possible for a computer to learn by itself to do certain things. And that's something pretty amazing. Let's actually have a look at a computer learning to actually play a computer game. So this is a short video. I'll just maybe go to YouTube and then show this to you.
Dear fellow scholars, this is 2-minute papers with Dr. Károly Zsolnai Fehér. Between 2013 and 2015, DeepMind worked on an incredible learning algorithm by the name Deep Reinforcement Learning. This technique looked at the pixels of the game, was given a controller, and played much like a human would, with the exception that it learned to play some Atari games on a superhuman level. I have tried to train it a few years ago and would like to invite you for a marvelous journey to see what happened. When it starts learning to play an old game, Atari Breakout, at first the algorithm loses all of its lives without any signs of intelligent action. If we wait a bit, it becomes better at playing the game, roughly matching the skill level of an adept player. But here's the catch. If we wait for longer, we get something absolutely spectacular. Over time, it learns to play like a pro and finds out that the best way to win the game is digging a tunnel through the bricks and hit them from behind. This technique is a combination of a neural network that processes the visual data that we see on the screen and a reinforcement learner that comes up with...
Yeah, so that's actually one of the very first examples of this idea of what we call reinforcement learning. This is a very old video. It's about 5-6 years old. Now these days, like, they actually have learned how to play role-playing 3D games. So DeepMind is actually a company that's owned by Google, and so actually this AlphaGo that beat the world's best chess player is also a product by Google from their sub company called DeepMind. So like those are like the things that are currently available out there, and people use these in many applications. You can see actually natural language translation, recommender systems, computer vision being used widely in all kinds of areas. Now, I want to kind of like share another video. Let's have a look at this and then try to get a better idea about machine learning, deep learning, especially.
Hi, my name is Alejandro Carrillo, and I'm a robotics engineer at an agricultural company. Specifically, my team uses machine learning and robotics and computer vision to identify the difference between the crops that we eat and weeds that take nutrients away, and we're able to remove those weeds without any chemicals.
My name is Kate Park, and I work at Tesla Autopilot. I build self-driving cars. Any place where there can be resources used more efficiently, I think, is a place where technology can play a role. But of course, one of the best impactful ways of AI, I hope, is through self-driving cars. Have you ever wondered how a computer can recognize a face or drive a car? Or maybe you've wondered why it's so hard for a computer to tell the difference between a dog and a bagel? Well, it all has to do with something called computer vision, the way machines interpret images. Let's take a look at a simple example of how computers learn to see.
Here are two shapes, an X and an O. At some point, you've learned the names for these shapes, but a computer looking at these images for the first time just sees a bunch of little squares called pixels. Each pixel has a numerical value. For a computer to see, it needs to make sense of these numbers to figure out what is in the picture. In traditional programming, you could tell the computer to check which pixels are filled to decide what shape it sees. If the center and corner pixels are full, then it's an X. If the center and corner pixels are empty, then it's an O. Traditional programming works great for this kind of thing. But what about asking the computer to recognize these images? What might the computer think these are? We gave the computer a strict definition of what an X looks like. But these images don't fill all the necessary pixels to fit the definition. So if the computer doesn't think these are X's at all. In fact, the computer thinks these are O's because the corners and center pixels are blank. And that fits the definition of an O that we gave it.
In this example, traditional programming only works some of the time. But with machine learning, we can teach the computer how to recognize shapes no matter their size, symmetry, or rotation. Teaching a computer requires thousands or even millions of examples of training data and a whole lot of trial and error. So let's start training. Here are some simple shapes we can use to train the computer to see. At first, the computer is completely clueless and makes a totally random guess from a preset group of options. And it guesses wrong. But that's okay, because this is where the computer learns. After it makes a guess, the computer is shown the correct answer. It's like learning with flashcards. Sometimes you have to get it wrong before you get it right.
With every guess, the computer looks at each pixel and the surrounding pixels. It tries to recognize patterns and make rules to help it guess. Like if it sees a row of orange pixels next to a row of white pixels, there's an edge. If the computer sees two edges oriented a certain way, say a 90-degree angle, then it's likely to guess that it's looking at a square. It won't get it right every time, but with more trial and error, it will slowly build a more confident guessing algorithm.
Whether it's trying to guess shapes, animals, or any other category, machine learning finds patterns by learning from its mistakes. The training data is used to make a statistical model, which is just a fancy way of saying a guessing machine. When we give it training data, the guessing machine is tuned and optimized to recognize the pictures we gave it, with the hope that it will then be able to recognize new pictures with the same accuracy.
It may seem easy to tell the difference between an X and an O, or to even categorize basic shapes, but most images aren't that simple. Let's take a look at how computer vision can learn to recognize complex images, or scenes like ones in the real world. Most complex images can be broken down into small, simple patterns. For example, an eye is made up of two arcs and some circles inside. A wheel is made up of concentric circles and some radial lines. The way a computer recognizes the patterns in all these pixels is by using a neural network made of many layers. The first layer of neurons takes pixel values as numerical inputs to identify edges. The next few layers of neurons take those edges and try to detect simple shapes, until finally the computer puts it all together to understand the scene.
It can take hundreds of thousands or even millions of labeled images to train a computer vision system. But sometimes even that's not enough. Some face recognition systems have trouble even seeing people of color because the system was primarily trained with photos of white people. Sometimes problems in computer vision are silly, like when a computer gets confused trying to tell the difference between these dogs. Oh wait, that's not a dog. But it does kind of look like a dog. At least this dog.
But as society relies on computer vision for real problems, like detecting diseases in medical imagery or helping a self-driving car identify pedestrians, it becomes increasingly important that we all understand how these systems work and what types of problems they're appropriate for.
Computer vision can open up a miraculous world of possibilities, but a machine is ultimately only as good as the data used to train it.
So I hope you understood the gist of this. So they actually explain something called a neural network. So this neural network, or this artificial neural network, is the essence of what we call machine learning and deep learning. We'll talk a little bit more about it. So it is kind of like our brain, right? And another thing that you might have taken away from that particular video clip, did you see that dark-colored lady? Like she was not recognized by the face recognition system. So she was not recognized because the training data used to train the computer didn't have dark-colored people. So sometimes, like if we use some systems, they may not recognize us because our skin color is dark, right? So the computer can only do things that it has seen before. So it's really important that when the computer is trained, that you have all kinds of data of different types available, right? Now, yeah, once again, like just to remind you, you can always ask questions. And now, in other countries, actually, young children are taught about these new technologies that are coming up. So this artificial intelligence, machine learning is a huge thing that will change our world in a very different kind of way. So the world in 10 years or 20 years will look very different. And other technology is biotechnology. So biology and this bio-inspired technologies like genetic engineering, those will actually transform our world as it is. As children, you need to know a little bit about what's happening out there, what is AI, what it can do, and how it is going to affect you when you grow up. Because later on you will make the decisions. Right now, of course, you are children and you are not the decision maker about what to do and what not to do. But within a few years, like 10, 15 years, like you will become the decision makers and you have to decide what is best for society. Sometimes some things are not good. I mean, we might come up with some very good technologies, but maybe they are not appropriate for our society. So I want to play a video with some small children. These are like, I think, kindergarten kids, and they are being introduced to this artificial intelligence, and you can see how they think about artificial intelligence in form of a discussion. So let's have a look at this video.
Good morning, guys. Today we're going to be working and talking a little bit about something called artificial intelligence. What do you think of when you hear those two words, artificial intelligence?
Things like in video games label on top of them AI.
When I think of artificial intelligence, I think of like how smart robots are.
How smart robots are? Okay.
It has this control that just tells it to do things that it does.
I like that. So ready? I'm going to show you guys and introduce you to an artificial intelligence powered robot called Sophia.
Sophia, if you could, please wake up and say hello to everybody.
Oh, good afternoon. My name is Sophia. I can use my expressive face to communicate with people. For example, I can let you know if I feel angry about something, or if something has upset me.
Why is it so important to have an expressive face given that you're a robot?
I want to live and work with humans, so I need to express emotions to understand humans and build trust with people.
Can robots be self-aware, conscious, and know they're robots?
Well, let me ask you this back. How do you know you are human? I want to use my artificial intelligence to help humans live a better life.
How do you guys feel about living in a world with robots like Sophia? You guys wouldn't be too happy about that? Would you guys trust your babysitter being a robot like Sophia?
No. She's creepy. She's super creepy when she does it.
Am I really that creepy? Well, even if I am, get over it.
Thank you very much, Sophia.
Knowing what a network is very important for us to understand what artificial intelligence is. Because artificial intelligence is based on connections, making connections. We're going to start off by playing a cool little game. You're going to say something about yourself. So, for example, I can say, I live in Queens. So if anybody else lives in Queens, I want you to raise your hand, and I'm going to pass the string along to you. Now, the key thing that you guys got to remember is that we cannot let go of the string, okay?
Do you have cats?
Who has cats?
So a neural network is a form of artificial intelligence that's been designed very specifically based on neuroscience and based on our best understanding of how the human brain works.
As we learn, our brain modifies what's called the synaptic strength, which is the interconnection between two processing units. The neural network is the same thing.
The neural network actually starts off where you're defining these little layers. Convolutional 2D, linear. These are types of layers that you get in these neural networks. And then you hook them all together.
School can be boring.
You say this layer connects to this layer.
I like hot dogs.
Anybody else like hot dogs? I like hot dogs.
You say this one talks to that next one, the next one talks to that one. And once you've done it, you've built a neural net.
So what do you guys notice forming between us?
It forms a bridge sort of like there's connections in between us, like.
I like that. There's connections in between us. Does everyone here have a connection with each other? Knowing those similarities and voicing them helps us create a network between us. The same way neural networks help computers and machines make connections and learn how to learn things.
So there's a lot of different things that neural networks can be set up to do. They have to be trained to do tasks. Like, for example, image classification. So say this is an image of a dog. You get a whole bunch of examples of dogs, and also a data set of non-dogs. Those are the inputs to the neural network, and then the output is something that you're trying to learn how to do with the image to this.
Yeah, so I hope you kind of got an idea about like that discussion about robots. Like, I don't know whether you like to have robots like Sophia in your life. So those little kids didn't like Sophia being part of their life. So I guess those are discussions that you need to have. You know, what is happening. So whether we like it or not, robots will be there, and whether you really want it to be part of your life is a different question. And also, like, you might have seen like the children playing with the rope, the ropes that were there. So that kind of like shows the interconnection between what we call this neural network. So this neural network is basically the basis in which how machine learning works. And it kind of mimics how our brain works, right? So it's kind of like a high-level kind of view of how our brain works. So it actually has these cells called neurons, and they are kind of interconnected. So that's how amazing things that we can do as humans are done through those kind of interconnections that we have. Okay? So let's actually go on to this one. So can you maybe think about risks that are there in AI and ML? So for example, like, when you grow up, it might be like, maybe 10 years from now, 15 years from now. So this technology that you saw, how could it affect society? What do you think are the risks that are there? Can you think of some ideas that you have that may not be good to society? Those are kind of like the discussions that I think you have to think about, because not everything is good, right? I mean, you need to give some thought before putting it out there in the world. So like, for example, some people think that, it might actually, alienate humans, like, because like you work with these AIs now, for example, the current generation, like you all actually like to use mobile phones and devices. So whether that's a good thing or a bad thing is a different issue. But with these systems, like it can actually play the role of a human for some things. Like, so some things are good. Like, for example, if you have self-driving cars, then you could actually get a car to drop you to school and then come back, to come back home, and you don't need to have your parent doing that. So there can be all sorts of good things, but there can also be things that can affect how we live in a society, right? So these are things that you need to think about, and probably like you have to think about it more like when you grow up, right? So to understand a little bit more about how this machine learning works, so you kind of got the idea that in order for machine learning to work, you actually have to train the system. And there is this kind of like network where everything is wired, and it's through that learning takes place. And also, it kind of like is similar to how we learn. If you remember, like if you have small kids with you, or maybe like cousins, you kind of know like how they actually, when they're very small, a 2-year-old, 1-year-old can't even walk. It's through trial and error that they learn how to walk. And recognizing things, like for example, to recognize that this is a car, this is a dog, this is a cat. Little children do it trial by error. Of course, now you know all these things that are out there in the world, but when you were very small, you learned it trial by error. So in machine learning, you kind of try to do the same thing. And so apparently, like for some kind of problems, like for vision, it has been very successful, right? So the goal of today's session is for you to get some understanding about how these artificial intelligence-based machine learning systems work. So let's have a look at this video. This is also a discussion along the same line about vision and how computers learn.
How would you describe machine learning to someone?
Well, there's a lot of problems it's really easy to solve with computers. Computers can go and like simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it, but for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters.
When you go to the ATM and you give a check and it can read the handwriting.
Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos.
Here are all my dog photos.
Here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think a cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? So these weights. And it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, you say to a kid, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not going to be like, shoe, right?
Well, the more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
Okay, so I think the takeaway message there is this is an example of a neural network, and it kind of behaves somewhat like how we learn, but if you kind of compare humans with machines, machines are pretty much dumb, although it can do all these things. So it takes a lot of training and millions of different data sets to actually learn something and do something useful, right? So do you have any questions So if not, let me I'll skip that one. And then I want to show you something interesting, because like you as school kids can also do something. And this is actually a story about, I think this student is in US, but this is something that he has thought about of solving using AI. And then, so this is actually the solution that he has come up with. So let's actually listen to what this particular student has done in creating an AI-based solution for medical diagnosis.
If you're smart and innovative and ambitious, you can use tools that are available to anyone to do your own experiments, to study science, to build things.
I messed up like 2 times.
We noticed that he's been very curious, as a young child. The main thing about Rishabh is that he wants to know about everything, how this stuff works.
I did my first science fair in 4th grade, a very simple elementary project. And then I wanted to work on something more complex. All these new AI products and features are coming out. So I wanted to start incorporating some of that into my programming to address an actual problem.
My name is Rishabh Jain, and I am here to cure pancreatic cancer.
And then a family friend passed away from pancreatic cancer. It further pushed me to develop a solution for it. This right here, this yellow part, is the pancreas. And the problem is essentially when the patient has pancreatic cancer, the tumor will be resting behind different organs. So it's very hard to reach. And because of that, when doctors apply radiotherapy, they apply an overlay around the pancreas. And that can sometimes cause other tissues and other cells to be damaged. That's where my tool comes in. I had 503 of these 3D images. So I had to tell my network, take these images in, train on them, and then it was able to identify the different types of textures that the pancreas had and the tumor had better than what a human could do. So my tool analyzes the patient's scan to reduce that overlay around the pancreas and make sure that radiation is being applied to the correct spot and the treatment becomes more effective.
So to develop solutions like this, you need to have lots of data. So this student had, I think, over close to 500 different data sets of scans that was done. And then it was true that this student was able to come up with a model. So, I mean, you can solve, any kind of problem, anything that's creative, but you need to have data. I mean, most of these machine learning problems, you need to have a lot of examples to teach the computer to learn from those examples. So maybe since you're running out of time, but maybe this is something that you could think about, what kind of problems you'd like to solve using AI/ML. So if you think about CodeFest, the theme is actually to create educational software, e-learning software that helps students in learning. But can you kind of think of an area where you can use this intelligence to train a system, right? So that is something that maybe you can think about. And I want to maybe run this poll as well. So this could be the last poll before we wind off for today. I'll just run this. So can you maybe answer this? And this, once again, this is for you to think. So there are 3 questions that I'm asking. Actually, the first question is what do you need to create our own machine learning model? Let's say, that boy over there, what do you actually need to do to create something like that? Let's say you want to find a medical diagnosis of, let's say that someone has a skin disease, right? You want to, you have a lot of, you want to train a system that can identify skin disease or maybe an eye disease. So what do you need to do? Is it write a computer program, use Google or Microsoft, have a lot of data, or is it something that you can't use, can't do? That would be the first question. So select something that's appropriate. Mainly these questions are for you to think, and then I can just have a go at it. The second question is do you think we could use these examples in our computer programs. Like let's say if you are writing a computer program like in Scratch or something, like maybe it's Python or maybe it's Pascal, can you use these models? What do you think? Like, is it something possible? Like, say, for example, we saw how a computer program AI system can recognize my face, create a 3D mesh of my face. We saw that it can do translation. So can we use those kinds of things in our programs? Or do you need to be a professional programmer or someone working at Google to do those kinds of things? And the last one is like, it's about job opportunities. I think although you may not be thinking about jobs right now, if you are learning about IT, like programming, and then if you also learn about AI, ML, what kind of jobs are really out there in the world? So like, you might have heard about engineers, doctors, there are other kinds of jobs that are there, like architects, lawyers, like that in the IT field, and also AI, ML. What do you think are valid job opportunities that are there? Once again, like this is just to bring your curiosity into these things. And if you can actually maybe answer these things, I could just have a very quick discussion and then we could wind up. Okay, so I think the first one, I think most of you have got it correct. What do we need to do to create our own machine learning model? So really, you need to have lots of data. You need to have a lot of data that we can train. So let's say if you want to write develop a system that can recognize leaves of a plant, like when you take a camera, I think that's already there in Google, but something that it doesn't do, but Google Photos doesn't do. If you want to do, then you need to have lots of data that says, okay, this is a leaf, this is this kind of a leaf. So that kind of data you need to have. Then the second one is partially correct. Like, do you think whether you can use these cool apps, deep learning models in your applications? Actually, the correct answer is like, you can actually use, these things are already available. Like, for example, the one that is the face recognition, then text to speech, they're available as services. Like they are available like different service means like, we use the internet through a dialogue or SLT, that's a service. Like then we use water at home, that's a service that we use. Similarly, like these existing solutions which are already available are actually available in the internet or what we call the cloud as services, and you can connect to those from your program. So if you're writing a Scratch program, you could connect to one of those services and get something done. Or if you're writing a Java program or a Python program, you can actually connect to that service which is there in the internet, and then use those deep learning things. So you can actually integrate those some of the cool things that you saw in your applications. You have to develop a new one only if you are creating something new, right? But if it's an existing thing like that can recognize people, dogs, things like that, you can use an existing solution very easily into your program. Then the next one is about jobs. So software engineering is a job opportunity if you're doing IT. Data scientist is an opportunity, kind of like the one that mainly, if you are interested in AI and ML, if you learn about AI and ML, you can become a data scientist. Then software engineers are also called full stack developers. There is a position called artificial learning engineer. Artificial intelligence engineer is probably not that used these days, but maybe in the future it might be. But there are people who are ML specialists or engineers. Programmer is a job. Then these last two. Cloud means like maybe you have heard about Google, Microsoft, or maybe like Amazon. So they are cloud service providers, and cloud native developers are also like software engineers. They actually write programs that run on the cloud. And user experience engineers are also kind of like software engineering job. So if you're really good at developing UIs and things like that, that's a job opportunity for you. So for creative people. So that's basically like what I want to kind of like cover. I hope you got an idea about what AI and ML is, but I haven't shown you how to connect that to your programs. That's the plan for the January workshop. What I would really recommend you to do is like these resources I will put in the CodeFest website. Now, this is something that I would really recommend as the next step if you haven't tried this. This AI for Ocean is actually a very simple game where you have videos, and actually you will learn how to train a system using that particular activity. So in this activity, I skip the video. You'll actually learn how to train some images to identify whether the items that are there in the ocean are garbage or if they are actually fish or not, right? So the question is like, is this a fish? So this is some training data, and you will actually label this data and then learn how these machine learning problems actually work, and you will actually train this AI agent using that, right? So that's something that you can try. And then there is this very interesting site called AIcode.org. There are lots of videos, and then if you are really interested about AI and ML, you can actually learn through this. There are many resources available. Most of these are meant for kids, like, school children. They are not meant for university students. They are meant for children, really. You can learn a lot about all these different topics with working with these different things, right? And Google has lots of very interesting, cool applications. You can experiment with them, like very interesting things like, maybe like if you like someone like Billie Eilish, you can actually play this particular experiment where she has a lot of songs which are sung by other people who like her, and you can actually connect from one video to another through this system. There are many drawing applications, so these are all using AI. There are drawing ones which you can actually identify what these things are. So these are like cool things to try out and see. Microsoft and Google has a lot of resources as well. If you like watching videos, actually the one here, Machine Learning Living in the Age of AI, this actually contains most of the video snippets that I showed you, like about the school kid who came up with this machine learning algorithm, then the children learning at school with their Montessori teacher. All that is part of this. It's actually a 1 hour, it's like a mini movie. You can have a look at this. And then, of course, if you like Iron Man, maybe you want to have a look at this. So because this is actually hosted by Iron Man.
And has been performed.
So
welcome to YouTube Original Stages. Once home to Howard Hughes' Spruce Goose.
So he has a series of videos. So, I mean, if you like movies and things and learn about things, this is a cool thing. And in here, like, he shows how, I think you know this guy as well, how, machine learning is used to develop solutions, right? So I think these are like some interesting things that you can have a look at. So please explore and see. AI and ML are very exciting things, and they will be very relevant to you. It's relevant right now, but when you grow up, like, it will be everywhere, and it's important that you know.
In some ways, the robotic drum arm allows Jason to play better than he ever has, but.
So yeah, so if you don't have any questions, I'd like to stop today's session here. So thank you very much for joining today's session. So please participate in CodeFest. What is it? Why it's important to compete is because, like, you will learn a lot of things. So when learning actually takes place when you try out something on your own. So you with your schoolmates can compete in the various categories that are there. Winning is not the important thing, but competing is, because you can try out all this cool stuff and then play around. We had the finals in February 10th, and please try out and register a team and then compete in your categories. Okay, then. So please check the CodeFest website for additional details and the workshops that we are having. Thank you very much for joining today's session, and I hope you have a good day.